Have you ever wanted to track your daily expenses using your own Python application? In this video, we'll build a complete expense tracker using Python and Tkinter. You'll learn how to take user input, validate data, store expenses, display them inside a list, and calculate the final expense total automatically. And one more thing. I've also included a small homework challenge for you at the end of the video. If you can complete it, you'll level up this project even further. Also, I'll explain every important line and the logic behind it in detail. Some repetitive or self-explanatory lines will be covered a little faster, so we can focus more on understanding the core concepts instead of repeating the same ideas again and again. So let's get started. First, we're importing Tkinter. Tkinter is Python's built-in library for creating graphical user interfaces, also known as GUIs. Instead of working with a boring console window, Tkinter allows us to create buttons, text fields, labels, list boxes, and complete desktop applications. We're also importing messagebox.messageboxes, allow us to show warning messages, error messages, and information pop-ups to the user. This line creates an empty list called expenses. Every time the user enters an expense amount, we'll store that amount inside this list. Later, when we need the total expense, we'll simply add all values stored inside this list using Python's sum function. This small list is actually the core data storage of our project. Here we're collecting data entered by the user. The get method retrieves the text written inside the entry field. The strip method removes unnecessary spaces from the beginning and end of the text. This helps prevent issues where users accidentally enter spaces. Before doing anything else, we need to make sure both fields contain data. If either field is empty, we immediately show a warning message and stop the function. Validation like this is extremely important because it prevents invalid data from entering our application. This pop-up gives immediate feedback to the user and improves the overall user experience. Everything entered inside an entry widget is received as text, but expenses are numerical values. That's why we convert the amount into a floating point number. An expense amount should never be 0 or negative. This condition ensures that only valid, positive expenses can be added. What happens if a user enters something like ABC instead of a number? Python would normally crash. To prevent that, we're using a try except block. If conversion fails, value error is triggered, and we show an error message instead of crashing the application. Once validation is complete, we store the amount inside our expenses list. Remember, this list is where all expense values are stored for total calculation later. Now we display the expense inside the list box. The user can immediately see every expense that has been added. This makes the application much more interactive and user-friendly. After adding an expense, we clear both input fields. This saves the user from manually deleting previous values. This automatically places the cursor back into the category field. Small touches like this improve usability and make the application feel more professional. This function is responsible for calculating and displaying the total expense. Before calculating the total, we first check whether any expenses exist. If the list is empty, calculating a total doesn't make sense. So we display a warning message. This is one of the most important lines in the project. The sum function automatically adds all values stored inside the expenses list and returns the final total. This line updates the label displayed on the screen. Without recreating the label, we're simply changing its text dynamically. Finally, we display the total expense in a pop-up window, so the user gets instant feedback. When the exit button is clicked, this line closes the application completely. From this point onward, we're mainly designing the graphical interface. Most of these lines create labels, buttons, entry fields, and layout positioning. The logic is very similar throughout, so I'll cover this section a little faster. This creates the main application window, sets the application title, defines the window size. This connects a button with a function. When the button is clicked, the corresponding function runs automatically. And there we go. Our expense tracker is now successfully storing expenses, displaying them in the interface, validating user input, and calculating the final total automatically. Now it's time for the homework challenge. I mentioned at the beginning, your challenge is to add a delete expense button. The user should be able to select any expense from the list and remove it. After deleting, the total expense should update correctly. Try implementing it yourself before searching for the solution. This challenge will help you practice list manipulation, selection handling, and GUI event management. If you learned something new from this project, don't forget to like the video and subscribe to the channel. Keep building projects, because that's where real Python learning happens. I'll see you in the next one.